Forces. Forces are vector quantities F vector. This means that forces can be added or multiplied while taking their directions into account. The net force acting on an object is defined as the vector sum of all forces acting on the object. We sometimes refer to the net force as the total force, the result force, or the unbalanced force. Contact forces and field forces. One class of forces is called contact forces. That is, they involve physical contact between two objects. Examples of contact forces are the force exerted on a ball when it is kicked and the force exerted by your feet on the floor. Another class of forces is non-contact forces, also known as field forces, which involve no physical contact between objects, but instead acts through empty space. The force of gravitational attraction between two objects is an example of a field force. The only known fundamental forces in nature are all field forces. Gravitational forces, electromagnetic forces, strong nuclear forces, weak nuclear forces. Newton's first law: when no net force acts on an object, its acceleration is zero, which means that an object at rest remains at rest, and an object in motion continues moving with a constant velocity, that is, at a constant speed in a straight line. No net force, acceleration is zero. Newton's first law is expressed as sigma f equals zero, v is constant, acceleration is zero, and rest with your constant velocity, constant speed, and a straight line. No net force, equilibrium. The words no net force mean that the vector sum of all external forces is zero. Vector equals zero. The words the absence of external forces mean that no external forces act on the object. F vector equals zero. The word an isolated object means that the object has no interactions with its surroundings, that is, no external forces act on it. Inertia: the tendency of an object to resist any attempt to change its velocity is called the inertia of the object. Inertial frame of reference. An inertial frame of reference is one that is not accelerating. Because Newton's first law deals only with objects that are not accelerating, it holds only in inertial frames. Any reference frame that moves with constant velocity relative to an inertial frame is itself an inertial frame. The best approximation to an inertial frame is the distant stars. For many practical purposes, the Earth and any other frame attached to it are also treated as inertial frames, since the various accelerations of the Earth's motion are much smaller than g and can often be regulated. Mass. Mass is a measure of inertia, the tendency of an object to resist changes in its motion. If an object has a greater mass, that is greater inertia, it undergoes less acceleration when an applied force acts on it. Mass is a scalar quantity and therefore obeys the rules of ordinary arithmetic. The SI unit of mass is the kilogram. Mass is an inherent property of an object, that is, it is independent of its surroundings and of the method used to measure it. Mass should not be confused with weight. The weight of an object is the magnitude of the gravitational force exerted on it, mg. Because it depends on g, weight varies with geographic location. Hence, weight is not an inherent property of an object.